All right, so I'm going to start going over all the problems in this practice test dealing with systems of linear equations and linear inequalities. So what I would advise if you're, studying or preparing for a test is, to try the problem ahead of time, so like maybe try this ahead of time, you think you can do it. Then check back by unpausing the video and see like how well you're doing as you guys are, going through these problems. So, pause the video, try to do it, unpause it and see how you're doing. But if you're completely lost, obviously you want to, start, with me, because I'm going to go over a lot of problems in this video. But here I go. So the first set of problems, we're going to be graphing these linear equations. And then when it says identify the solutions, you want to just see where they intersect. Wherever they intersect, if they intersect, it's going to be a solution. So here we have y equals negative 3x plus 4. Negative 3 is the slope. 4 is the y-intercept. So we go to 4 on the y-axis. And the slope is negative 3. So that means you go down 3 to the right 1. Down 3 to the right 1. Connect it. That'll be our first equation. Next, we have y is 1/2 x minus 3. Y-intercept is negative 3. So I go to the y-axis, plot a point at negative 3. Slope is 1/2. So going up 1 and to the right 2, up 1 to the right 2. And you can see that they intersect over here. I didn't draw my line perfectly. Need to work on that. But they would intersect at this point 2, negative 2. So that's your solution. Now your solution is an x and y value where if you plug these values into each equation, they would work. I'm just going to go through this first one just to make sure you guys really understand this. So if I want to go through this problem thoroughly to make sure I did the problem correctly, I would plug in 2 for x and negative 2 for y. So I would get negative 2 equals negative 3 times 2 plus 4. Negative 2 is negative 6 plus 4. And yeah, see, for the first one, we got the true equation. And to check, it's supposed to also work for the second one. I would plug in 2 and negative 2 in for x and y. So I'm going to get negative 2 equals 1/2 times 2 minus 3. I would get negative 2 equals 1 minus 3. 1 minus 3 is negative 2. And again, negative 2 is negative 2. So that's what you can always do with these systems. You can usually always check them. So obviously, it's going to take some more time, but especially like when you're doing a test, I advise my students with any extra time, you should check your answers, especially if you're not sure you graphed it right or maybe made like a silly mistake. I'm not going to do it for every problem in this test, but just know this because that's a great technique to help you make sure you are doing all the problems correctly. All right, problem B, the equations aren't solved for y yet. So let's put this in slope-intercept form by first adding 2/3 x both sides. So I'm going to get y is 2/3 x plus 3 for this first guy. Graphing this, go to the y-intercept at 3. Slope is 2/3. The rise is 2. Run is 3. So up 2 to the right 3. That's my first line. For the second equation, I'm going to subtract 4 from each side. I'm going to get y is 2/3 x. Whoa. Minus 4 y-intercept is -4. And then the slope is also 2/3. So up 2 to the right 3. Up 2 to the right 3. Now, see, these lines are parallel to each other because they both have a slope of 2/3. So they're never going to intersect. So there actually is no solution to the system because they don't share any common points. Now, like, if you wanted to check this, it's like, well, how do you check to see if, how if this solution is right? Like the first one, we had a specific point to plug in, and you can't really do that because the lines don't intersect. What you could do is, you basically just want to make sure you graph the lines correctly. And you could just pick a point, check, maybe it's 3, 5, if that would work for this equation. And maybe another point here, like 3, -2. You plug it into here, that should work as well. So that's another way to check. All right, moving on to problem C. All right, so here again, we got to solve for y first. Let's take away 4x. So we get 2y equals -4x plus 2. Then divide everything by 2. And we get y is -2x plus 1. I'm going to call this y1 just so we have different names for the lines. Y-intercept is 1. Slope is -2. So I'm going to go down 2 to the right 1. Down 2 to the right 1. That will be y1. All right, second equation, let's start off by taking away 9x from both sides. So we'll get -3y equals -9x plus 12. Then divide everything by -3. I'll get y is +3x minus 4. And we'll call this y2, just so it's a different name. Y-intercept is -4. The slope is 3, so I go up 3 to the right 1. And you can see the intersection here. Keep on going, up 3 to the right 1. Connect these. And your solution is going to be this point here at 1, -1. All right, and one more of these guys. So solve for y again, add x, and let's add x and add 6 to both sides to begin with. So we'll get 2y equals +x plus 6. Then divide everything by 2. And we'll get y is 1/2 x plus 3. We'll call this y1. Y-intercept at 3. Up 1 to the right 2. Up 1 to the right 2. Y1. Now for the second equation, let's add x to both sides. So we'll get -y equals +x. And then divide every term by -1. And we'll get positive y equals negative 1x or just negative x. And we'll call this y2. Now the y-intercept here is 0 because this is the same as negative 1x plus 0, but we don't obviously write plus 0. So we have the y-intercept at the origin, then slope of negative 1. So we go down 1 to the right 1. And we're going to see our intersection over there. And our solution will be at 2, negative 2. Or no, negative 2, positive 2 is what I meant to say. All right, cool. All right, next up, practice with some linear inequalities. So remember, linear inequalities have this, well, inequality symbol, like it could be less than, it could be greater than, less than or equal to, greater than or equal to. They're pretty much like equations, except they're going to either be dashed lines or solid lines. And then you have to decide if we're saying less than or greater than. So start off by first getting y by itself. So we're going to take away 1/2 from both sides. So we'll get negative 3/2. Y is less than negative 3/4 x plus 5 plus 1/2. Now 5 plus 1/2, that's just like 5.5. You can say 5. Well, actually, let's do this. Let's leave it at 5.5. 5.5 for now. Now, we need to get rid of this negative 3/2. So we're going to multiply everything by negative 2/3. I'm going to go through all the work. So multiply everything by negative 2/3 because that's the reciprocal of negative 3/2. That's not negative, whoops. Negative 2/3. There we go, negative 2/3. Pretend I didn't mess up there. So negative 2/3 times negative 3/4x plus negative 2/3 times 5.5. But if we write 5.5 as a mixed fraction, that's the same as 11/2. Okay, so then again, I'm just reviewing this because I know a lot of students I get are very scared of fractions and they forget about how you deal with them. Okay, so first thing, when you multiply by a negative, we're going to flip the inequality symbol. So this becomes y is greater than. All that cancels. And then these 3's cancel. Then we get 2/4. 2/4 simplifies into just 1/2. And it's just going to be positive because we have a negative times a negative. So we have 1/2 x there. And then these 2's cancel. And I just caught a mistake that I made. Wow. Whew. This is why good thing I checked this. So at the beginning, let me go back, and this is why I write in, or should write in pencil. I should have taken away 1/2. So then instead of getting 5.5, I should get 4.5. And then instead of this being 11/2, this just becomes 9/2. Not a problem, not a problem. Let me know if you caught that mistake. That'll be interesting. But yeah, My bad. Anyways, what's good about this is that then these numbers work out nicely because these twos cancel, and then you just get 9/3 or negative 9/3. And negative 9/3 is just -3 because 9/3 divides equally. And we get this. We get y is greater than 1/2 x minus 3. Plotted just like a linear equation, go to -3 on the y-axis, up 1 to the right 2. Now, since this doesn't say greater than or equal to, it just says greater than, this is going to be a dashed line. Don't think it's like not a big deal because it really is, especially if you guys play sports. Like this means the line itself is not included in the solution. Think of it like in some sports, like when you touch the sidelines or like in tennis, like if the ball hits the sideline, it's still in bounds. But in basketball, if you put your foot on the sideline, you're out of bounds, or if you step on the 3-point line, it doesn't count as a three. So the line itself is like important. And we're saying greater than. So greater than, we're talking about above, because the y values become greater or larger above this line. So then our solution is all of this region. So what this means is that any point in here will make the inequality true. It's going to work. I could plug 0, 0. Like I could plug 0, 0 into here, for example. And I would get like 0 is greater than or equal to 1/2 times 0 minus 3. And we get 0 is greater than -3. And that's correct. Any point in here will make a true inequality. All right, one more of these guys. So let's start off by adding 3/2 x to each side. So if we get negative 2y is greater than or equal to positive 3/2 x plus 4. And here we're going to divide everything by -2. These -2's cancel. Y, this switches because we're dividing by a negative number. When you multiply or divide by a negative number, remember in inequalities, you got to switch the direction. So we got y is less than or equal to. And again, if you need some refresher on fractions, -2 is the same as -2/1. So a fraction divided by a fraction, this is the same as 3/2 times -1/2. So then multiply across, so we get -3/4. And this is just 4 divided by -2, which is just -2. And here we're saying y is less than or equal to, so we're talking about below the line because we're saying less. I like to sometimes use arrows to symbolize. So we're talking about downward below this line. So let's graph this line. Y-intercept of -2, slope of -3/4, so down 3 to the right 4. And this is going to be a solid line because we're saying less than or equal to. So we include the line in our solution. I'm having trouble here. Let me try to. There we go. So below this line. So right in this is going to be our solution space. All right. Okay, now we're going to look at one where we have, now we're going to look at one where we have two inequalities. So a system of inequalities. So the only real difference is you got to, deal with two instead of one, kind of just like systems of equations. So start off, let's graph this first one. y-intercept of 4, slope of 1, because it's the same as 1x. So we go like this, up 1 to the right one. And this is saying greater than or equal to. So we're saying above this line. So a tip that I like to give my students, the ones that especially that kind of struggle with the geometry, is I say go to one side of the line, draw an arrow upwards, directly upwards, because we're talking about greater than, and go to the other side and draw another arrow upwards. So then we know so far it has to be in here, that the solution is not going to be here. Then we graph the other one. Y is greater than 6x minus 3. Slope is negative, or y-intercept is negative 3. Slope is 6, so we go up 6 to the right one. And this is going to be a dashed line. It's pretty steep. And we're also saying it's above this red dashed line. So go to the one end again, directly upwards. So again, parallel to the y-axis. Because again, we're saying, right. So greater than again. So above this line, greater. And go to the other end and like right over here. And upwards of it, upwards like that. And let me extend this line a little further. This graph only goes up to 5. And this dashed line would, keep on going like that. So this helps, or hopefully I think it helps some students. If it doesn't, sorry. But when you have two diagonal lines that cross, you're gonna make 4 areas. So you're gonna have, let's say, one over here. You're gonna have a second one over here. You're gonna have a third one over here. And you're gonna have a fourth one over here. So you got 1, 2, 3, 4. Anytime you cross 2 lines, you're gonna have 4, 4 different regions or 4 different areas. And you want to figure out which of these regions, 1, 2, 3, or 4, have both arrows or satisfy both inequalities. This is a little tough to see, but let me darken them. Again, we had this other graph up here. Let me erase this line actually so that it doesn't get in the way. There we go. See, 1, 2, 3, 4. So then you can then see more easily that region 3 is above the red line and the pencil line. So then your solution is going to be this part, this portion over here. We're not going to include this one. We're going to just include all that top left area. So if that helps, great. If it doesn't, I'm sorry. But I know sometimes, especially with steep lines, it can be a little confusing. Okay, so a couple more challenging ones of these ones. And again, especially if you want to see how well you're doing, pause the video before you see me do the problem, and then once you have the problem done, or pretty much done, unpause it and see how your answer compares. Here I go. I'm gonna start off by taking away negative 5/8 x because I want to again get y by itself. So again, negative 1/2 y is greater than negative 5/8 x plus 5/2. Then I'm going to multiply everything by negative 2/1, or divide everything by -1/2. So multiplying everything by -2/1. I'll go through the steps, even though it's maybe a little bit messy. These cancel. Inequality switches direction, so I get y is less than 2 times 5, or 10 over 8x -10, or these 2's cancel actually, so I just get -5. And 10 and 8, you can divide them each by 2, so you get 5/4 x minus 5. Okay, so I start off with this line, go to -5 on the y-axis, up 5, to the right 4. And we're going to have a dashed line. Now, excuse me. It says y is less than, so we're talking about below this line, so arrows downward. So we know that. Again, go to one side, arrow down, other side. So we know it's going to be something below here so far. Next, in inequality, start off by taking away 4/3 from each side. I'll get 4/3 y is less than or equal to -4x minus 4/3. Multiply everything by 3/4 to cancel out the 4/3. Remember, -4 is the same as -4/1. So that times 3/4 as well. And this times 3/4 as well. These cancel. I get y is less than or equal to. This keeps it negative. These 4's cancel. I get -3x. And these both cancel, but this doesn't go away. Common thing my students will, a common mistake is they'll just think this goes away and it's like 0. But this is just 1. Because these all simplify into 1/1. And don't switch in the inequality symbol because we didn't multiply by a negative. So it stays the same direction. And again, we have less than, so arrows down. So let's graph this, go to -1 on the y-axis, down 3 to the right 1, up 3 like that. This is going to be a solid line because we're saying less than or equal to. Let me go further. And we're saying below this line, so arrows down on each end. And again, now see we have 1, 2, 3, 4 possible ways to graph. And we're going to graph the one again that satisfies both inequalities, or C has both arrows, and that's going to be region 4. Because region 4 is the only one that's going to be below both of these lines. All right. All right, one more of these guys. Start off for problem E. Add 2 to both sides. We'll get -2/3 y is less than or equal to -4/3 x plus 2. I left a space because I know we're going to have to multiply by a fraction. So we're going to multiply each term, by -3/2. 2 is the same as 2 over 1. So doing that, these cancel. We get y is, this switches direction again because we're multiplying by a negative. We get y is greater than or equal to, these 3's cancel. We get a positive because the negative times the negative is a positive. 4 over 2 is just 2. 2x. These 2's cancel, and we get a minus 3. Go to minus 3 on the y-axis. Slope is 2. We're going to have a solid line because it says greater than or equal to. Greater than or equal to, so above this. Arrows up. We know it's going to be something up here. Second inequality, let's take away 3 and 2x all at once. Or let's take away actually 3 first. So we'll get negative 3 halves y is greater than negative x minus 3. Oh, that's not correct. Negative 3 halves y plus 2x is greater than negative x minus 3. And then we're going to take away 2x from each side. So we'll get negative 3 halves y is greater than negative 3x minus 3. Then we're going to multiply everything by negative 2 over 3 to cancel out that coefficient. So negative 3 over 1 multiplied by negative 2 over 3. Negative 2 over 3. These cancel. You get y is, we're going to switch the direction. So y is less than. These 3's cancel, and we just get a positive 2x. These 3's cancel, and we get a positive 2. So y is less than 2x plus 2. So go to 2 on the y-axis. Up 2 to the right 1. Now this is the dashed line, so we're going to leave it dashed. And this says less than. So below this dashed line. And here it's pretty cool because it makes it like, I think I'll always see it as like a canal or a river. It's going to be this region in here, trapped in here. Theoretically go infinitely, but just graph whatever you have whatever you have space for, and that'll be your solution. All right, I'm gonna pause right now, get some water. Hydrate. Make sure you stay hydrated. Math is fun. You gotta stay hydrated to perform at the highest level. All right, so it's about halfway through with this guy. Okay, now let's look at problem 3. This is a cool one because then you can see a shape being generated. So we start off the same. Now, this will sometimes throw students off. We see negative 3x because we don't see any y's in here. So just approach it by solving for x. So divide everything by negative 3. So we get x is, switch the direction. X is greater than or equal to 6 divided by negative 3. So x is greater than or equal to negative 2. So negative 2 on the x-axis, we just draw a vertical line. Because remember, in an equation, it would just say x is equal to -2. So that means the x value will never change. And x values never change on vertical lines. Why does this line look so crooked? Let me redo this. I don't like the way it looks. Maybe the paper is crooked, or the printer. My eyes are crooked. Oh no. Let me try again. A little better. So we're saying x is greater than or equal to -2. So we're talking about to the right of -2, because x values get bigger as you move to the right. So for now, we know that's going to be to the right of this line. Now for the next one, y is less than or equal to 2. We just make a line at 2 on the y-axis, but it's going to be horizontal because the y value always stays at 2. So these ones are actually pretty simple if you just don't get this mixed up. Now we're saying less than or equal to 2, so downward, below this line. So then we narrowed it down to over here, somewhere in this bottom left. Or no, sorry, bottom right. Next one, we're going to solve for y. Add 2/3 x, or add 2/3. We get -1/3 y is less than or equal to -1/2 x plus 2/3. Multiply everything by 3, or by 3/1, same thing. Or -3/1, actually. So -3/1. These cancel. We get y is, this is going to switch direction because we're multiplying by a negative. So y is greater than or equal to +3/2 x. These threes cancel. We get -2. We're saying greater than, so arrows upward. Go to -2 on the y-axis. Slope is 3/2. Up 3, to the right 2. Draw a solid line. Whoa, let me get this. All right. And we're saying above this line. So then we know it's in the bottom right. If it's above this line, it's going to be somewhere in here. Oh, excuse me. Somewhere in here, maybe this triangle, but we have one more line to go. The last one, we're just gonna solve for y again. And I'm gonna even bring the y to the left. So I'm just gonna flip everything. I just liked having the y on the left. So this is the same as -y plus 3 is greater than or equal to 2x. Don't overthink it because it's just, again, it's just, I just like having the y on the left. Then we take away 3, so we get -y is greater than or equal to 2x minus 3. And then let's divide everything by -1. So we get y is, and we switch the direction, y is less than or equal to -2x plus 3. So y-intercept is 3. Slope of -2. Down 2 to the right 1. And it's also going to be below this line. So again, you can just kind of use logic and see what the area, or in this case, this shape that's trapped between these four lines, and it would be this guy right here. It would be just a quadrilateral. You could say trapezoid, but actually not trapezoid. It would just be a quadrilateral. Interesting. So quadrilateral, four-sided polygon. Quadrilateral. So take your time with these ones because they're actually not that difficult, but they can kind of seem like they're hard because you have a lot of like inequalities, usually more than two or three. Okay, this next problem, let's practice now writing inequalities because we're kind of going backwards. These are like not really involving steps, but they're kind of just analyzing. So we just have one inequality. So just look at the slope, maybe plot points. First, you can see the slope here is 2. Slope is 2 or 2 over 1. Y-intercept is -5. And it's below this line. Below, so we can say y is less than, and it's dashed, so we can leave it as y is less than 2x minus 5. Not much more to it than that. Here we got a horizontal or vertical line. So we know we're just going to have an x variable. And we're shading to the right of this line. So that's going to be x is greater than, because values of x get greater as you move to the right. Dashed, so we leave it as greater than, and that's -3. So x is greater than -3. All right. Third one. This is one that students sometimes overthink and get confused. The slope here is -1, first off. The slope is -1. The y-intercept is 0, because it's the origin. And we're talking about above this line. So greater than. The y is greater than or equal to, because we have a solid line. I can zoom in case it's a little hard to see this one. So y is greater than or equal to, and we can say -1x or just -x. You can even go as far as -1x plus 0. This would be right. Or you can just write it, y is greater than or equal to -x. They're both the same. So don't overthink those ones. All right, for the fourth one, slope of 2, it looks like. Y-intercept of -1. Downward, so we're saying less, because it's below the line. Y is less than, it's a solid line, so y is less than or equal to 2x minus 1. And these next three, now we look at multiple inequalities. So again, just do it one by one. So first focusing on this dashed line. It's a little hard to see, but we know it's above this line. Slope is 1. Y-intercept is -3. So we have y is greater than, above, because again, it's greater than that line. Y is greater than x, or 1x minus 3. And the other one, slope is -2. y-intercept is 4. And we're talking about below this line because we're this region only. So here we're going to have y is less than or equal to, because it's a solid line, or equal to negative 2x plus 4. And put this, the brace symbol, because they're cool, and also means you have a set. So we have, this is our system. And again, try these on your own if you want to, see how you're doing really. So pause the video whenever you want, and then try the problem, and then unpause it when you want to check. So here we got, this is a good one. We have this line here. Oh, and this one's, you can see that the slope is meant to trick you, but it actually doesn't matter what the scale is, but 1, 2, 3, but you can see up 3 to the right 2. Technically, the slope doesn't matter. You can, you can say this is 3/2, or you can, calculate it to be 6/4. Same thing. It doesn't matter. But we know it's going to be above that line. So slope of 3/2, y-intercept is 2. And above this line, so we have y is greater than or equal to 3/2 x plus 2. And then the vertical line, remember that'll be x. In this case, it's to the left of this. So we say x is less than, and it's dashed, so we leave it as less. And whatever that value is, it's 3. So x is less than 3. We're talking about this area, top left. And that'll be our system for that. All right, one more. So below this top line is at 5, 2, 4. It's weird, actually. What would that be? The scale doesn't make any sense, actually. 2, 4, 6, 8. Oh, no, it's not. 1, 2, 3, 4. It's going by ones. My bad. So below this top line, so y is less than 5 for that top line. Above this bottom line, y is greater than 2. Or I guess y is less than or equal to 5. Y is greater than or equal to 2, the bottom one. And then we look at these other ones. They're parallel, so they both have the same slope. Both have a slope of 3, actually. Y-intercept of 1. Let me write them first. So y would be, it's going to be below this first line up here. So y is less than or equal to 3x plus 1. The red line here, the slope is still 3, but it's above this line. So y is greater than or equal to 3x. And it would scale down to 4 if you were to calculate 1, 2, 3, because it goes through here, and you can calculate to be -4. But then let's throw the other 2 into the system. Doesn't actually matter the order if you put them in, but put them all into this brace, and there we go. All right, cool. Let me get some more water. Okay, now down to the final section of this practice test, systems of equations, where we're going to practice using our substitution or elimination method. I like these ones. Students usually do too once you get good at them. But I have 8 of them here, so a lot of good practice. I think, or no, maybe more. I think I might have 10. I have 10 to go through. So let's go through them. Okay, so now what I'm going to go through these in just one way, but no, there's more than one way. But you should always get the right solution or the same solution if you do them correctly. And you want to again get good at knowing what to do, or what the fastest way is. So for this first one, you can see that the y's have opposite coefficients, 3 and -3. So what I would do is just add these. I'm going to put the big plus there. I'll use elimination by adding these because I'm going to have 1x plus 2x, which will give me 3x. 3y plus a -3y gives me 0y, or just 0. And 6 plus 9 is 15. Then I solve this for x. I get x is 5. And then from here, I just plug this 5 into either equation. The top one looks simpler. And here I'll get 5 plus 3y equals 6. And then I just solve for y. Take away 5, 3y equals 6 minus 5, or 3y equals 1. Divide by 3, I get y is 1/3. As an ordered pair, my solution is 5, 1/3. And again, don't forget what this means conceptually or graphically. This means that if you were to graph these two lines, they would intersect at the point 5, 1/3. All right, next one. So here, you could argue that it's probably quicker to do substitution. From what I understand, technically computers use elimination because it's usually always going to require less work, but sometimes you want to avoid dealing with bigger numbers, but it doesn't matter. So if I were to solve the second equation for y, I would make this equation, solving this for y, I would take away 5x from both sides. I'll get y is equal to -13 minus 5x. And then this, I would plug this portion in for the y from the top equation, because that's going to give me then an equation written entirely in terms of x. So I'd end up with 6x plus 6 times a -13 minus 5x equal to -6. And I just solve this for x. 6x distributing the 6x minus 60 minus 78 minus 30x equals -6. Combining the x's, -24x minus 78 equals -6. Adding 78, -24x equals 72. Dividing by -24, I'll get x is -3. Whoa. Get this pencil going. Okay, now what I should do is plug this -3 into the equation for y, plugging it into this x here. And that'll give me y is equal to -13 minus 5 times -3. And we'll get that y is equal to 2. And together, my solution would be the point, or the ordered pair, -3, 2. Don't make the mistake of plugging this -3 back into the top, because you're gonna get like you're gonna just recycle get like a pointless equation because that's where we got this from. So plug it into the other equation. All right, next one. Let's do another elimination method here where you can see, let's make the x's the same. So what we're going to do to the top one, see, let's make both of these 6 because 2 and 6 both go into 6, obviously. I'm going to make the top 6 by multiplying by 3. That's a times 3. Let me actually go down here so there's more space. And make sure you multiply everything in the top by 3. So I'll get 6x plus 3y equals 60. Now stacking the bottom one, putting the bottom one right below it again. 6x minus 5y equals 12. See, then I can just subtract these from each other because the x's will cancel right away. So I make an equation bar, subtract 6x minus 6x, 0. 3y minus a negative 5y is the same as 3y plus 5y. So plus 8y, 60 minus 12, 48. 8y equals 48, divide by 8. And we'll get y is 6. And then plug this y into any equation because you want to eventually get x. The quickest one will probably be on the top one because I see a 2x there. I'm going to plug it into there, that spot there. So I'll get 2x plus 6 equals 20. Take away 6, 2x equals 14. Divide by 2. X is 7. And my solution as an ordered pair is 7, 6. All right. So problem D, the fourth one. Again, you want to get to a point, you want to know, like, you want to be able to see things quickly. And it's just practice. But if you look at this, you can see the x's are almost opposites. Like we have -3 and positive 3x. To cancel those, you just add these. I'm going to use elimination method by adding these equations. Just like that. -3x plus positive 3x and make it 0. -4y plus 3y and negative y. 2 plus a -3 and -1. And see, I have -y equals -1. And right away, just divide by -1. And you get y is +1. And I can find x by just plugging 1 into the bottom one. That one looks quicker. I can plug it into either one, but the bottom one looks quicker. So I'm going to plug it into this y here. Recycling. I'll get 3x plus 3 times 1 equals -3. This is just 3, obviously. So I'm going to take away 3 from both sides. I'll get 3x equals -6. Divide by 3. I'll get x is -2. So my solution together would be the ordered pair -2, 1. All right. And I just had an hour working on this. So yeah, it's a I mean, I've done it for an hour, so I know that you guys have probably been doing this for more than an hour. But it'll pay off. Again, this is a good unit to get a lot of what I say, a lot of systematic practice, and this builds a lot of confidence. Anyways, I'm just rambling to kind of help you power through the last 6 problems here. Okay, so 6 more of these guys. Let's get this. So Right here, this is kind of one of those annoying ones. Got to think now. What two? We have a 2, a 7, a 6, and an 8. I'll probably shoot for both of these going into 24 to make them both 24. So to make 6 24, I'm going to multiply by 4. To make the 8 24, I'm going to multiply by 3. So I'm going to write it again down here just so it's more clean. So let's first focus on the top one. Multiplying everything in the top equation by 4, I'm going to get negative 8x plus 24y equals 4 times 6 equals 24. Multiplying everything in the bottom equation by 3, I'm going to get negative 21x plus 24y equals negative 15. Equation bar. And I'm going to subtract these because I can get rid of these 24s by subtracting them. Negative 8x minus negative 21x. That's the same as negative 8x plus 21x, which will give me 13x, or positive 13x. These cancel. 24 minus a negative 25 would make a 24 minus a negative 20. 24 minus a negative 50. Oh, 24 plus 15, duh. 24 minus negative 15. I almost screwed up there too. It's 39 because it's adding 15. Oh yeah, 13x divided by 39, or 13x equals 39. Divide everything by 13. Sorry. Look at x is 3. Oh, okay, so now we just plug this 3 in for x and solve for y. Let's plug into this top one here. We get negative 2 times 3 plus 6y equals 6. Negative 6 plus 6y equals 6. Add 6. We get 6y equals 12. Divide by 6. And we'll get y equals 2. Not sure why I said it that way, but 2. Okay, yeah, then our answer would be the ordered pair 3, 2. Okay, nice. All right, problem F. This one could be, see, you can make them both 10, or make both of these, I think, 56, or solve this for y. If you want to avoid fractions, let's make both of these 10. Doesn't matter if one's positive, one's negative, just make them both 10. So the top, we're going to multiply by 2. I'm going to squeeze them over here. So we get negative 10x minus 16y equals 34. The bottom one, I'm going to multiply by 5 to make it 10. So 10x, 5 times negative 7, negative 35y. 5 times 17, or negative 17, negative 85. And I'm going to add these because a negative and a positive cancel when you add them. the big old plus sign here. So negative 10x plus a positive 10x, those go away, 0. Negative 16y plus negative 35y, negative 51y. And 34 plus a negative 85, that would be, a negative 51. Oh, nice. So yeah, negative 51y equals negative 51. So then y is obviously going to be 1. So y is 1. Then plug the 1 into any equation. Let's plug it into this is the bottom one. 2x minus 7 times 1 equals negative 17. 2x, whoa, minus 7. But let's just add that 7 to the negative 17. 2x equals 24. Or no, negative 10. It's negative. And divide by 2, and we get x is negative 5. So my solution together is negative 5, 1. All right. I really have to use the bathroom. So I'm going to pause the video. And again, feel free to try these again. I'll try these ahead of time, but I have to really go to the bathroom. I'll be back. Okay, final 4. Let's get to it. And the next one, they're both out of line, I guess. It's hard to find something that all of these go into, so I guess we just have to divide everything. Let's solve the bottom one for x. Because I think that'll be smaller. We divide everything by or the top one for y. It doesn't matter. Actually, top one for x. So take away 18y from both sides. So we get then. Make sure my camera is working. Yeah, take away 18y. So we get 9x is negative 18y plus 126. So we're going to use the substitution method. Divide everything by 9. Get x is negative 2y. 90, so that's 36. I don't want to use a calculator. 90 is 10 plus 4, so 14. 14 times 9 is 126. Last time I checked, which was just right now. 90, yeah. Okay, so this is our equation for x. Okay, so now I plug this into this bottom equation for x. So I get an equation just for y. So we're cycling around. I'll get 14y equals negative 7 times negative 2y plus 14 plus 98. Now I solve this for y. 14y equals 14y. Distributing that, negative 7 times 14 minus 98 plus 98. These cancel. So I get 14y equals 14y. Or 0 equals 0. So let's see if you remember what this means. It could be either, and the common ones are, students will always narrow it down to infinitely many solutions or no solutions. Now, the way you know it's infinitely many solutions is because this is a true statement. 0 is equal to 0. If it was no solution, it would be like 0 equals 1 or 0 equals 20. It would be a false equation. So this is infinitely many solutions. Don't write infinite infinity or an infinite, because don't do this, because that's, not the same as this. This is saying that this is basically, and the infinity refers to the number of solutions there are, which means there's a countless amount. Yeah, don't just, got to respect the infinity. Not this. It's going to be this. All right, H. Last three. All right, fractions and decimals. I know students love this. Let me go through this in detail. Substitution method looks like the best to go. So we have an equation for y already. So let's plug this into this y here. Let me put that in red. So then the top becomes 1/4 x minus 3/4 x plus 3.75 equal to 2.25. See, now I got an equation just in terms of x, and I just solved this. So 1/4 x minus 3/4 x, they got the same denominator, so we just do 1 minus 3 on top. So -2/4, but don't subtract the denominators. -1, -2/4 x, or -1/2 x. Whoops, and then make sure you distribute this negative to also the positive 3.75. So this will be minus 3.75. And let's rewrite that now as -1/2 x. Add 3.75 to both sides. We'll get 3/6. -1/2 x, multiplying both sides by 2, or -2, let's say, then makes it so that x is -12. And then, since we have an equation for x, or for y here, we just plug this -12 into this x. And let's go down here, or over here. And then we can solve for y. We'll get y is 3/4 times -12 plus 3.75. -12 times 3. 3/4 is -12, or 3 times -12, -36/4. In either case, or in either case, we'll get y is -9 plus 3.75, which then is -5.25. And so the solution together would be the ordered pair, -12, -5.25. You can also write this as a -21/4 as a fraction. I'm okay with decimals as long as they're not approximations. Like, don't have like a rounded decimal. Don't like bust out like 8 divided by like 17 and then round this to 0.47. I would leave the answer as 8/17 in that case. But if it's like, again, 2 over like 10, we know that's 0.2. Or no, whoops, 2 divided by 10, 0.2. That's okay because it's exact. That's what I usually tell my students. That's a different story. Final two. Okay, so you can probably spot what you want to use here. Elimination. You can make the x's or the y's the same. Multiply the top by 2. Multiplying the top equation by 2 because you can make then the x's both 12x. So we'll get 12x plus 6y equals -24. Keeps the bottom the same. 12x plus 6y equals -36. And look, we got the exact same expressions on the left. Now, if what I do here, times 2, yeah, times 2. So then I could just subtract these. 12x minus 12x, 0. 6y minus 6y, 0. Negative 24 minus a negative 36, 12. So I get 0 equals 12. This is false. 0 is not equal to 12. So this would be no solution because you get a false equation. And we can just stop there. This would just be parallel lines. You did this graphically because, again, parallel lines never intersect. So then there's no solution. Yeah, because going further down that, if you were to solve each of these for y, they would be the exact same equation, the exact same slope, except just different y-intercepts. All right, one more. Another one you could probably see right away, it's elimination. You can make both y's, make them both 8. Make both of these 8. We're going to multiply the bottom one by 4. And let's keep the top the same. Let's put the top on the same over here. So 56x plus 8y equals negative 32. The bottom one, when you multiply by 4, you get 4 times 14x, 56x. 4 times 2y, 8y. 4 times negative 8, negative 32. And you can see what's going on. You get the exact same equation on both of them. If I were to keep on going further, subtracting them, I get 0, 0, and 0 again. So I get a true equation and get another infinitely many solutions. All right. So there you go. That was this is a good review. I give you a lot of problems. I always tell my students when I make these practice tests, I then tend to make them 2 to 3 times as long and put problems that tend to be more difficult. It took me over an hour to do this just on my own. So yeah, like this would be solid studying for you guys to ace that next math test. So I hope that helps. Let me know if you have any questions or you were wondering maybe like what I did, or if I explained something too fast or explained something confusing. Like I'm a teacher. I'm used to criticism and feedback. So leave comments. Also, let me know if you thought it was a good job. I'll take those too. And of course, subscribe because that's going to motivate me to make me feel like I'm actually doing something useful with my life. Obviously, in addition to teaching, of course. And here's my duck. So good luck, and I'll see you guys in the next video.